Okay, let's start. So let's go through a bunch of examples, make sure we have this derivative thing down. We're going to go through the list of examples I gave you via email. If we have time left over, I'll probably do some problems from the quiz, because I don't think starting a new topic and running through it in 5 minutes is going to be good. Did they actually do any of these examples in the list for you guys before? Or not?
I don't think so.
I think in one of my classes I did a few of these. So we're just going to have an examples class here. So find y prime, basically, or find the derivative. Just write it like this. So this just means find the derivative with respect to x of the function x cubed e to the x. Okay, how do we do that? Product rule. Right, so we have two functions being multiplied. So there's a multiplication here, so we apply the product rule. By the way, what does the product rule say? Repeat the product rule, write it as a rule.
Derivative of f, right?
It's the derivative of f times g. Right? It's very important that when you learn a rule, you learn both sides of the equation. There's a psychological reason for this, which I'll probably explain later. But let's kind of just run through it. So it's the derivative of something, one function times another. It's
the derivative of f times g plus the derivative of g times x.
Okay, and we're going to do the same thing. So you think of someone in your head as the f and the g, or you can write that down, and you're just going to apply that. So what's the derivative of f? 3x squared, that's the power rule. And then you multiply that by the g, which is e to the x, plus, now you leave the x cubed, and you multiply by the derivative of e to the x, which is e to the x. That was what's special about e to the x. And you can leave it that way. I mean, you can factor if you want. It depends on the context, really. But you could pull out an x squared e to the x here, and leave this as 3 plus. Either one of these is sort of okay. There will be times when we want to plug in solve for when the derivative is 0, and so in those situations, factoring is definitely how far you want to go. But otherwise, you only have to simplify to ask for it. 2. How do you deal with that one? Same rule. How do we apply it here?
Derivative of square root of x is 1 over 2 square root of x.
Well, this we already know. The derivative of that is 1 over 2 radical x, so I can go 1 over 2 radical x times e to the x plus radical x times e to the x. So this is your f prime, this is your g, this is your f, this is your g prime. If you forgot that, it's no problem, because you just could think of this as x to the 1/2 times e to the x. And then you apply the power rule. So this is 1/2 x to the minus a half e to the x plus x to the 1/2 e to the x. And it's the same. So either of these. Great. The derivative how do you do this one? Same. Product rule, still a multiplication of functions. That's your f, that's your g, so you're going to do your product rule. Differentiate this one, you get what? 6x by the power rule, leave the ln x alone, plus now you leave the 3x squared alone and multiply the derivative of ln x, which is 1 over x. So that's pretty easy to simplify, so I'll do that. So that would be your answer. Or you could factor out a 3x into ln x plus 1.
One question.
Yeah.
Could you like take out the 3 at the beginning of that to take a constant?
Yeah, the constant factor said I could have taken that 3 out and do it here, and then it would have just always been in front in anyway. What about this one? You could use the same rule. There's actually an easier way though. Could you do this without the product rule? Yeah.
You can make it an x and a 1/2 and then multiply them.
Okay, so you can think of this as x to the 1 times x to the 1/2, which is x to the 3/2, and then you apply the power. Okay, now if you did the product rule, that would be fine, and you would eventually be able to combine the terms and get back to one single term. So you could have done that as well. But there's virtue in attempting to simplify an expression before you actually take derivatives. A lot of the problems on your quiz would have been a lot easier if you simplified them. You could have again thought of this as the product rule, f and that's g, and so it's 1 times radical x plus x times 1 over 2 radical x. You notice that this cancels into that, leaves you with a radical x. And so really you have radical x plus 1/2 radical x, which you can combine those into 3 over 2 radical x, which is the same thing. But for something like that, I would have simplified it and used the power rule. Sometimes the quotient rule and the product rule are overkill. What about this one? 5. How would you use the product rule?
The derivative of x plus 1 times x plus 2.
Quotient rule.
Quotient rule, yeah, that's what I
Quotient rule, right? So this is a division. So now we have f divided by g. And what is the derivative of f divided by g? The formula. It's,
minus derivative of g times x
mhm.
over g squared.
Right. Bottom times derivative of top minus top times derivative of the bottom over the bottom squared. So that's what we're going to do. So the derivative of f is what? 1 times the g, which is x plus 2, minus f, which is x plus 1, times the derivative of the g, which is
1.
also 1, over the g squared. Now you can simplify this one a little bit. This is x minus x, and you have 2 minus 1, so you end up with 1 over x plus 2 squared. How about this one? The derivative of x squared over 2.
Factor out the 2.
You can factor out the 2, or as we kind of said, you can kind of ignore a constant in the denominator and just differentiate the top. That's just x. Right, so technically the quotient rule could work, but it's overkill, and students will often make a mistake because they'll forget that the derivative of 2 is 0. For whatever reason, that happens a lot. So if you see the top or the denominator of a fraction is a constant, don't use the quotient rule. It's overkill, and the likelihood of making a mistake when you're under pressure goes up. So here, when the denominator is a constant, you literally just ignore it, because what it is, it's the same as just leaving the half, factoring out a half, and applying the constant factor rule. So that will just be a half times the derivative of that. So it's the same as that 2x over 2, which we ultimately would get to here. So that's why if a constant is in the denominator, just leave it alone, differentiate the top. Right, so there are little shortcuts like that you can know. What about 7? The derivative of that. We pull the 3 up front, and then what? Then we'd have 1 over radical x. How do we deal with that?
It's easier to bring it to the top as x to negative 1/2.
You can bring it up. So this is just the derivative of 3x to the minus 1/2. So even though initially it presents itself to me as a division, it's probably overkill because the numerator is a constant. Just bring up the denominator, and now I can just do power rule. So let's just bring the minus 1/2 down and subtract 1 from the power. The next example, very similar. So I see something like 4 over x cubed. I wouldn't do the quotient rule, I would just realize that that's the derivative of 4x to the minus 3, and then do the power rule. So that's minus 12 x to the minus 3. Next page. So this example and those two examples kind of show you that the product and quotient rule, they're not always, you don't just always jump into them. Sometimes you have to be a little bit analytic. You have to analyze the problem and just say, do I really need the product rule here, or do I really need the quotient rule? Because sometimes it can make things more difficult. These are relatively simple examples, so we wouldn't have gone through much trouble with these either way. But there are times when it would be a lot of trouble to go through a rule that you don't necessarily need that kind of power. How would we do the derivative of ln x divided by e to the x?
Quotient rule.
Quotient rule, because that can't really simplify. Neither the top or the bottom is a constant, so I'll just jump into the quotient rule here. So now I think of this as my f, that is my g. So I'll do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I could simplify a little bit. I could factor out an e to the x. And this would cancel that. And if you don't like that 1 over x on the top, you could again multiply by x over x. And so you would end up with something like 1 minus x ln x over x e to the x. Now, odds are in your textbook, if a problem like this shows up, this is how the answer would look in the back, because your textbook won't put like a complex fraction as an answer. So you have to be aware of your algebra if you ever want to check your work. Just to make sure. If I ever want to write this guy without parentheses, what would it be? Yeah?
E to the 2x.
E to the 2x. I want you to be aware that that's e to the 2x. Very common mistake to write this, think of this as e to the x squared. That would actually be wrong. Okay, you want to make sure you remember. Laws of exponents still apply. They will apply forever. All right, you raise one thing to a power to another power, you multiply the powers. So e to the x squared is actually e to the 2x, right? Not e to the x squared. Just want to make sure, just checking that you guys remember. Did you guys work through all of the examples? it's good. So you can like check your answers, right? It's better to do that than to, you know, just actually watch me do everything. Let's look at 10. Derivative of e to the x ln x. Particle. So differentiate one, leave the second one alone, plus you leave the first one alone, differentiate the second one, and you have that. And again, you could factor out the e to the x if you want, but it's not necessary here. So make sure you're checking your answers against mine, and if things don't match up, you should ask me about it to make sure that you're not misunderstanding something. How do you do this one? It's chain rule, right? So there is an inside function and an outside function. You can imagine that if it were x to the 20, you'd use the power rule, but instead of x, you have the whole function to the 20th power. So you need the chain rule here. What does the chain rule say? If I have an inside function and an outside function, how do I differentiate that? Alright, so it's the derivative of the outside times the derivative of the inside, and when you're taking the derivative of the outside, you leave the inside alone in the first case. So for this guy here, so I think of this as just something to the 20th, and then I'm going to differentiate the outside, so I'm bringing the 20 down and leave that out here. So that's the derivative of the outer function, which is the power function. Leave the inside alone. This guy here is my g of x, the original. But then I multiply by the derivative of what's inside. I suggest you always use parentheses here. Strictly speaking, it's not necessary in this example because there's only one term. But if there were several terms, you need to make sure the distributive law does apply. So just use parentheses to be safe. You could then simplify this by taking this guy and multiplying this. 20 times 3, you can do that. That's 60x squared x cubed plus 1 to the 19th. One thing you do not want to do, because most times it won't be algebraically correct, don't multiply. And I saw people make similar mistakes on the first test as well. Into the parentheses. So you can't take this 3x squared and multiply the x cubed and the 1, because those guys are raised to a 19th power, right? This guy's not raised to a 19th power. You can't multiply them like that. And that's because of a law of exponents, right? So, in order for something to be inside parentheses, all raised to a power, each individual must be raised to the same power. That's a law of exponents. So this guy's not raised to the 19th power. You can't bring him inside the parentheses to the 19th power, because that would violate the laws of exponents. What's that?
Chain rule.
Chain rule? How do you apply it here?
You would write the same thing because the derivative of e to the x is e to the x 3 plus 1. And then you do times 3x squared.
Times the derivative of the inside. Which is
Yeah.
x squared. It's customary to write this in front.
Okay.
Right, so the rule that we memorized here is basically the derivative of e to the u, something I asked on the quiz. So the answer was u prime times e to the u. The derivative of an exponential is the derivative of the power times the original function. So it doesn't follow a power rule, for example. You can't just bring this down and subtract one from the power. It's not true for exponentials. Because the base is a constant, so things work slightly different. I will generalize this rule to talk about bases without e, other than e, in the next section. For now, that's what we know. About 13. I want to find the derivative of ln of x cubed plus 2x plus 1. Yeah, read it.
It would be the derivative of integral over, which is u prime over u.
Okay, so what's the derivative?
3x squared plus 2, and then over x squared plus 2x plus 1.
That would be the derivative. The rule you are using is the derivative of ln of something is. What's the rule? U prime over u. Right? So derivative ln of anything is just the derivative of the thing over the thing itself. So in this case, this was like the u. Right? So when the trick is you're using all these rules that I give you as sort of like templates, right? You're trying to fit this on top of that, and you realize, oh, this is in the position of u, therefore this is how I would do it. How do you differentiate that? Chain rule. Notice that 1, you can rewrite this. This is 2 minus x squared equals 1/2. And so you have an outer function, which is the radical, the 1/2 power, and you have an inside function. So you differentiate the outside, bring that power down, subtract 1 from the power, leave the inside alone. Then you multiply by the derivative of the inside, which in this case is just minus 2x. I can multiply that 2 by the half, and so this just becomes minus x times 2 minus x squared minus 1. See, tons of examples here. 15. Spoiler alert, quotient rule. Right? So this is your f, the bottom you think of as your g. So we need f prime times g, which is 1 times x plus 4 to the 16 minus f times g prime. What's g prime?
Chain.
Chain rule. So what does it become here?
16 x plus 4. 6 times 1.
What's x plus 4 to the 16th squared? X 4 to the 32, right? Going back to that previous example. You raise one thing to a power, you multiply the power. This one I'd simplify. Problem 18, we're going to actually go through that. X plus 4 is a common term. Factor out the lowest power. So now this can cancel with some of those. So it's 17. On the inside you have minus 16x. And it's minus 16 plus 1. And you would leave it like that. Yeah.
I will like it's 16 and we just have 1 and 15, so it will be x plus 4 minus 16 times x plus 1.
Oh, yes, you're right. That was to the 16. So this will be the top here. So it's minus 16x plus x minus 15x minus 16 plus 4 minus 2. Alright, good catch. We'll stop there, we'll do the rest later. I'll post a quiz soon, you guys can go over it, and then I'll probably also go over that next class, just give you some more examples. And call it a day.
I probably will.